Well, welcome to this series of 3 videos on getting a Raspberry Pi running as a standalone Alexa device. We'll do this in 3 videos. Well, the first one will be setting up the Raspberry Pi and installing the voice service. The second one will be registering the voice service with your device with Amazon, and the third one will be running the app and showing how it all works. So I've got a couple of notes on this, which I'll make available, and I'll run through these notes as we go along. I should just point out that, first of all, this mostly comes from this Amazon website here on how to do it all, except there are 1 or 2 things that I've found missing, or you might just want clarified to do this. That refers to a GitHub AVS device, Alexa AVS device SDK there as well. So we'll give you those links too. And we'll be using this later on. So first thing we need to do is some prerequisites. So I've got a Raspberry Pi 4, but it's an old one. It's only got 1 gigabyte of memory on board. They recommend 8 gigs is preferred, so we'll see how we get around that by increasing the swap size. I've started with a complete fresh new build running Bullseye. You'll need a microphone and some speakers, of course, otherwise you won't be able to talk to your device. And I've started with a complete fresh new build, and there's a couple of links showing you how to do that if you don't know how to do it. I've also updated my software and the distributions, cleaned it and rebooted the machine. There's a couple of links here on how to find out what you've actually got if you're not quite sure about your Pi. And also, I've run that initially using an SSS program called Putty. Very useful, but I quite like using the VNC code as well, which you'll see me use. And to do that, you need to set up the Raspberry's configuration command. So if you use sudo rasp config, you get a list of the screens and the things you can change in your Raspberry Pi. If you go down to VNC, it then says, do you want to start it? You say yes, and you tab it, just use the tab key to get to the finish and click finish. Now, the other thing you need to do is increase your memory swap size. And that's basically if you don't have 8 megabytes of memory on your Raspberry Pi 4. So you need to stop using your swap file. You need to use your editor to edit the swap file. And to do that, you need to basically give it the swap size that you want. I think it's a default of 100 megabytes. I've made it into 1,000 megabytes. So again, we've got a gigabyte of my mini SD card that's used for swap files. And you reinitialize and turn the swap on and restart your machine. The other thing you need to do before you can do all this is set up your microphone, headphones, and speakers. I've just got a USB microphone that's plugged into the top left-hand USB port, and that will give us device 00. And I've got just some headphones in 3.5 millimeter jack. But I'll do a whole demo of this running, and I'll put some speakers on so you can hear it going. To check this, you can just type a record -l, and it will tell you where your device is. So you need to configure a .a sound record or C file to suit your sound setup. This is the setup that I've got. And once you've done that, you should really test that it works. You can do a simple use a record to do a simple recording with this instruction, and that just carries on recording things until you hit the Control C to stop it, and then you can play back. And if that all works, then at least you know that your sound recording is working. If it don't work, then you may as well just stop there and just make sure it does before you continue. Okay, so let's carry on now and create the folders for our SDK. As I say, I use VNC, so I've got that here, and we're going to We're already in the home directory, but we'll do it anyway. We'll follow this. Oh, sorry. Oops, if you type in the right place. And we'll make a folder called SDK folder, and we'll change into that, and I'll just copy this and paste that. Make another folder. Now we need to install the requirements. We want the dependencies for the SDK. I'll copy that and I'll paste all that, and we'll let that run. So the next thing we're going to do is we're going to copy the SDK code from the GitHub I mentioned before. So while we're doing that, we'll just do a copy that. And how's this doing? 19%, 20%. I might as well just pause the video whilst that's going on. Okay, so that's finished. That took about 4 minutes. So we'll just see what we do next. Oh yeah, this is what we do next. Well, we're going to clone the SDK code, and we'll do a git clone. That's going to bring it across the internet from that website I saw before. Okay. I'm doing this over slow Wi-Fi in my room. It's not too bad. I'll pause it again just to save you. Oh no, it's done. There you are. Okay. Right. So port audio is used for the recording and the playback. So we'll set that up. No, that won't work. Always forget to do Control-Shift-V. And we'll add the port audio and the streamer. And now we're going to make the sample app. Now this took me 40 minutes on my Raspberry Pi before. And what I'm going to do is going to just try running it with, that was just with a single processor. So I'm going to risk it and run it with this dual processor. You might want to just run top while you're doing this, and it'll give you some idea of the processes that are going on and whether it's hung or not. So we'll just set these up, and we'll write make. Oh, wrong one. Make. I'm going to run it with two processors, and it's sample with a capital S. So PLE APP. Just see, so you can see all that. That looks good, and we'll run that. And this is going to say it's going to take some time to do, so we'll pause it while it's doing that, and I'll see you in about 40 minutes time. It certainly looks like it's faster running two processors. We're 13 minutes in, and it gets to this 93%, where I've often found that the processor really just sort of hangs and hangs and hangs, and you wonder what's going on. But if you look up here, you'll notice that the swap memory starts getting used quite a lot. So don't worry if it doesn't get back to you. Just keep an eye on what's running up here, and you'll see that there's some processes are running, and it gets back to you in the end. So we'll see you in a bit. Okay, we're at 95%, and you can see I've been joined by my cat, but also that the swap memory is getting rather a bit low. So if you are going to do this, then suggest you use the suggested 2048 that Alexa suggests. So we'll, where are we? 22 minutes in. Wow, and we finally get there, although it still took about 35 minutes, even running 2 processors. So we've finally built the target sample app, and that's where we'll stop for now. We'll just recap what we've done. We've set up our Raspberry Pi and basically installed the software that we need. So in the next one, we'll register our device with Amazon, and then in the third one, we'll authorize and run the sample app. Okay, see you soon.